Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Loopy Territories by Macetab, and here are the rules. It says it's Sudoku rules, but it's not actually Sudoku rules. Even by the normal rules that I would say, like normal Sudoku, where we need to fill in every cell, we need to fill in a digit from 1 through 9 such that there are no repeats in any row, column, or region. This does not satisfy that. So this is more of a Latin squares rule set, where we need to fill the grid with the digits 1 through 9 so that each digit appears exactly once in every row and column. So that's Latin squares. And we have a separate rule set for regions, where we need to divide the grid into regions of orthogonally connected cells such that every cell belongs to a region. So, for example, this is an example of an orthogonally connected region. What is an orthogonally connected region? It means that in the orthogonally connected region, you can go from any cell in that region to any other cell in that region just by going through edges while staying within the region. So, for example, to get from here to here, you can go through these edges and still stay within the region to get to this cell here. What is an example of one that is not orthogonally connected is something like this. For example, if these two cells can get to each other by going through edges while staying within the region, but to get to the other cells of the region, you have to either go through a corner or you have to go through an edge exiting the region, which is neither of which is allowed. So that's an example of how orthogonally connected cells in a region work. And each region contains exactly one circle, and every circle belongs to a region. The digit in a circle gives the size of its region. So, for example, if this were a valid region, this would then have to be 7, because the size of this region is 7 in size. The digit in a circle gives the size. Okay, digits may not repeat within a region except for in regions with a star, where at least one digit must repeat. So that's why this is not normal Sudoku rules, because there are two regions, this region and this region, where you must have one digit repeat, and you could have multiple repeats in that region. So that's the difference between normal Sudoku rules and these rules here. And we also have cells separated by a blue dot are in different regions. So this must be in a different region than this because there's a blue dot separating them, etc., etc. This is different. These are different regions because there's a blue dot separating them. Also, we have a loop where we need to draw a one cell wide loop of orthogonally connected cells, which passes through all circles in the grid. The loop may not touch itself, not even diagonally. So, what is an orthogonally connected loop? It's the same thing as an orthogonally connected region, where you can go from any cell in the region to any other cell in the region just by going through edges. But we also know another way of phrasing it is every cell on the loop must share an edge with exactly two other cells on the loop. And if they share a corner with a cell on the loop, they must either be neighbors or they must share a neighbor. So that basically forces the ability to not touch itself orthogonally or diagonally. So if this is an example of a valid loop, what would be an example of an invalid loop would be something like, say, I don't know. I'm trying to figure that out. Let's say, well, let's have it go like this. That's not going to work. Actually, I guess that could work. We'll do something like this. So even though this every cell in this loop shares an edge with exactly two other cells on the loop. These two cells share a corner, and they are not neighbors, and they don't share a neighbor. So that's why this is not valid. And that equivalence is basically considered touching itself diagonally, right? Another example of a invalid loop would be something, oops, that's not right. Something like, say, this. If we tried to go this way, it would be considered touching itself orthogonally. And the way that it distinguishes itself is this cell, these two cells share edges with three cells on the loop, right? This cell's an edge here, here, and here. This shares an edge here, here, and here. That's why this is not, that's why the rule, the explanation I have of a loop not being able to touch itself is valid, because it has to share an edge with exactly two other cells on the loop. And this cell shares an edge with three cells on the loop, which is invalid. So that's how an orthogonally connected loop works, which cannot touch itself. Again, every cell on the loop, on this type of loop, must share an edge with exactly two cells on the loop. And if it shares a corner with another cell in the loop, it must be a neighbor, or they must share a neighbor. And every cell on the loop the loop acts as a German whisper line. That is, adjacent digits on the loop must have a difference of at least 5. And I will be calling it a whisper 5 line because a setter came up with that example, and I thought it made a lot of sense because it's very easily extendable. So say this digit was a 3. Then the digits next to it on the loop must be 8 or 9, because they have to be 5 or more away from 3. And the only digits which can be 5 or more away from 3 are 8 and 9. And an orthogonally connected loop also means that you can only travel horizontally and vertically. You cannot go diagonally. So that's why this is an orthogonally connected loop. That's why you have to share two cells or two edges with exactly two cells on the loop. And that's how the loop works. We also finally have a white crop key dot separates two consecutive digits. So as an example, if this were, say, a 6, this would have to be 5 or 7 to be consecutive with it, because there's a white dot between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's first draw the boundaries. Do it around the entire grid and every blue dot. These are boundary, 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 boundary. Boundary here, boundary here, boundary here, and boundary here. So this cell is going to be part of either this region or this region. Again, each cell on the grid is on a German whisper loop. So, and since the loop can only move, so these are definitely part on the loop, because they have to be, it has to enter in one, every cell on the loop must share an edge with exactly two other cells on the loop. So these are on the loop. This is on the loop. Because this is on the loop, this must continue on the loop here, because we know all the circles are on loops. So it could loop that way. We don't know. Or it could go straight through. We also know that... How many regions do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 regions. Okay. So the sum of the digits in the circles must add up to 81 because every cell in the grid is part of a region and every region has a circle in it, and the circle is the size of the region. So therefore, the sum of these digits must add up to 81. You have to orthogonally connect. Well, you can't. Okay, so this is not part of the loop. I think we'll make them gray. This is not part of the loop. This has to connect as a loop there. So one thing about the loop, since it's a whisper 5 line / German whisper line, you'll always alternate between low and high digits on a whisper 5 line. Another thing you know is that because you can only go horizontally or vertically in this grid, and it's a loop, you know that it will, if the cell is part of the loop, it must be of one set of the two sets. It has to be guaranteed to be one type of set. So, and that is calculated by basically saying how many steps does it take to get from one cell to this cell. So since this is green, this is one set, these have to be the opposite set. This has to be the same set as that one, so this must be the opposite set of that. And that works any way which you get to any cell, right? So even if this goes some crazy way around here, back to here, these are going to be in the same set, right? Because you have 1, 2, 3. So it must go here to here. So same set, opposite set, 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 same set. And that's going to work for any cell that is on the loop. So you know the circles are definitely on the loop. So we're going to color these green and orange for the sets. So this must be orange. These have to all be orange because they're even digits away from this cell. So this is 1, 2, 3, 4. So same, difference. So green, orange, green, orange, green, orange, green, orange, green. So these are orange. This must be green. This is 2 away from that. This is 2 away from that. This is 2 away from that. We have green, orange, green, orange. So this must be orange here. This must be orange here. This must be orange here. Orange here. And this must be green because to go from here, you have green, orange, green, orange, green. We know this cannot be on the loop because it can't touch itself. So it goes to either one of these. We're not sure which one. This could go either that way or that way. This must go this way on the loop. Okay. We have 6 greens and 8 oranges. We do know the cells with a star in them must have one set of repeats. And since it's orthogonally connected as a region, that means it has to be at least 3 cells wide, right? You can go repeat here, and that's 3. So this has to be 3, 4, 6, 7, 8, or 9. Same with this. This is 3, 4, 6, 7, 8, and 9. One of them is going to have to be a 3 or 4. Okay. These are all the green digits in that row. So the remaining digits must be 5 or orange. So we'll mark these as, okay, so this cannot be on the loop. If this were on the loop, it's going to have to be orange on the loop or 5. And 5 can never be on the Whisper 5 loop because 5 or more, subtract 5 or more from 5, you get 0 or less. Add 5 or more to 5, you get 10 or more, none of which are normal Sudoku digits. So this cannot be, this, if it were on the loop, would have to be green. But we already have 4 greens in row 9. So this is not on the loop, therefore this loop must go this way. So this must go green and green here because this cell must share an edge with 2 cells on the loop exactly. So this is green and green. It must go to orange here. This is not on the loop here. It goes to orange there. So not on the loop. It could go here. We have 3 orange cells here. You could go green, green. You could also do some funky stuff here. We have 3 cells that are green here. We have 4 cells that are green here. So there cannot be any more green cells in column 1, and this would have to be green if it were on the loop, so this is not on the loop here. That means to connect... Okay, so this cannot go this way, because to connect we have to go something like... It can't touch itself. So this is not going this way. This has to go this way, which means it connects to here. That means these cannot connect because they would be considered touching itself. This must go this way there, so that's green. This cannot be on the loop because then it would be considered breaking it. This can go either of these cells. This is not on the loop. This will have to connect here somewhere. So it could do something like that. It could do something like this or this. But we don't know. This must go, it could go that way, it could go that way, it could go that way. So either of those are valid. We have 3 cells here that are orange. Does that help anything? Not really. Could be orange here. So that's not helpful. This connects to one of those 2. That's fine. Can we have 8 high digits here in the circles? Well, you would have guaranteed at minimum 6, 7, 8. 6. So 6, 7, 8. 6. And then 2 and 2. So 6, 7, 6, 7. So what happens if that's the case? 6, 7, 8. Well, we know this is the at least 1 through 4, if that's the case. So 6, 7, 8 is 21. Plus 6 is 27. Plus 6, 7 plus 6, 7 is 13. So times 2. 13 times 2 is 26. That's 53. Plus 10 plus 3. So 26 plus 27, 53 plus 10, 63 plus 3 is minimum of 66. So that's fine as a minimum. What happens as a maximum if these were high? Sorry, if these were low. Well, for one thing, this would have to be 3 or 4 at, well, we're trying to do maximums anyways. So 2, 3, 4, 4, 2, 3, 3, 4, and 3, 4. 3, 4 times... So 4 times 4 would be 16 plus 3 times 3, which is 9. So 16 plus 9 plus a 2. So 16 plus 9 is 25 plus 2 is 27. So this is the maximum amount here. Again, so 4 times 4 is 16 plus 3 times 3 is 9. It's 25 plus a 2 is 27. 6 through 9 adds up to 30. 30 plus 27 is 57. And then 8 and 9 is 17. 57 plus 17 is only 74. And that's the maximum if these are low. So orange cannot be low. Orange has to be high. And then these have to be low. So this has to be 3 or 4. We have 1, 2, 3, 4 here. This can't be 4. It's in between 2 unique digits on a whisper 5 line. This we don't know. These have to be 6, 7, 8, or 9. Interesting. So this definitely adds up to 10. And we have 17 at most for the blue circles. That means the red circles must add up to at least, what? 81 minus 17 is 64. Well, 9 times 4 is 36. 8 times 3 is 24. That's 60 already. 7 times 2, or it'd be 7 as an additional digit. I think that's what it has to be then, as a maximum. 9 times... Okay, so again, we have... This is maximum here for the blue circles is 1 through 4, which is 10, and plus 3 and 4, which is 7. We know the minimum is satisfied. So 3 and 4 is 17. 81 minus 17 is 64. Okay, so then... Yeah, then that gets above the 9. So if we have 9 times 4, that's 36. 8 times 3 is 24. That's 60 already there. And then we have one more red cell. So that would be 7. So we have, that adds up to 67. So that's 3 degrees of freedom. Which means any of the 9s could drop 3 and drop to a 6. The 4 could drop to a 1. So we're not guaranteed anything there. The rest of these digits, okay, so this digit must be next to 3 or 4, so this is 8 or 9. This is also 8 or 9. This is 3 in size or 4 in size. We have 1, 2, 3, or 4 in size here. Remaining digits of row 9 are 5 through 9. There must be repeats on these. So that's why this is 3 or 4 here. These digits are consecutive, and these digits remaining here, so this has to be 5 through 9 here. These are 6 through 9 here, obviously. 5 through 9 is only consecutive with 4 through 9 here. But if we have 8 or 9, I guess no, 8 and 9 can't work because that would force these 3 cells to have 6 and 7.
So that can't work with 9. Same with 7 and 8. That would force these 3 cells to have 6 and 9, which is too many cells trying to have too few digits. 6 and 7 doesn't work for the same reason. Therefore, we need a 5 here. So this is guaranteed to be 5. And you could have 5, 6, which would force this to be 7, 8, 9. But we're guaranteed a 5 there. Okay. What else do we have? These are low digits. That doesn't help us much. Oh, it cannot go this way. If it goes through this way, it would have to go through a 5, which can never be on the Whisper 5 line. So it has to turn this way, which means this is not on the loop. This must be high and must be on the loop, and it goes to one of these two, which would be a low. If it's low, this would be 4. That would be 9. That would be 5. We don't have anything consecutive there. This is okay. So this is high. One of these is low. We don't know which. It cannot touch itself, so this is not on the loop. It can't touch itself even diagonally. So then it must go this way, which means this is not 5. This is not 6. It's because it's between 2 unique digits on the loop. This can't be 4 then. Same thing. Okay. This can't go this way. Because if it did, it would be considered touching itself on the loop here. So therefore, this must be on the loop. And can't be 5 or 6. We have 7, 8, 9 triplets in row 9, which eliminates 7, 8, and 9 in the rest of the row. This is 5, 6 as a pair. This could go this way. So these are not on the loop because they would be considered touching itself. This must have a repeat, and it could just be repeated there. This must have a repeat, but we don't know how many digits. One of these is on the loop. Can this come up from here? No, but it could go that way. It could go that way. Okay. One of these is a 7. So this is guaranteed to not be 3 or 4 because one of them is guaranteed to be 7.
Hmm. This has to be 1, 2, or 3 because it's between two unique digits on the loop. This is 7, 8, 9 because it's on between two unique digits on the loop. 1, 2, 3 for that same reasoning. 1, 2, 3 also for that same reasoning. Hmm. What else do we have? Hmm. 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 This has to be between either 6 or a 7 here, guaranteed. Which means this cannot be 3. That's not too helpful. Hmm. Hmm. Mm, 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 mm. This has to go. This is definitely part of this region because it can't go out here. So it must either go out that way or that way. Um, I don't think this can ever be 4. If this is, well, maybe it could go 4 that way. That is possible. Hmm. Can this ever contain these cells here as a region? Um, I guess. Yeah, possibly. Hmm. Hmm. Where is 9 in this row? It has to be next to the 4 on the Whisper 5 line. So either 4 is here, which makes that 9, or 4 is here, which makes that 9. So this cannot be 9. 4 is next to one of these two, or this one. So 9 cannot be here. 9 cannot be here. 8 has to be next to 3. So 8 could be here or here or here. Uh, 8 cannot be here. Because either, well, you could have 3 and 4 here, which is next to a 9. So 8 could actually be there. Um, huh. This is size 1 or 2. This is 1 through 4. Hmm. So the thing is, this could extend to like here and do something funky like that, right? In fact, okay, so this is size 6. It could do something funky like that. So it doesn't necessarily have to have that as part of its region. Hmm. This either goes this way or it goes that way. If it goes this way, it could connect to something like that. This could do something funky like that. That is potentially possible. Or it could even do something funky like this. That's fine. Or it could go that way. That's fine. Hmm. Um. Hmm. Yeah, I'm trying to figure out where the next approach or the next tack is because I'm kind of sort of stuck. I'm not sure where to go next with this. Um. Hmm. One thing you cannot do, though, is go here and then connect to there. That loop is too small. So this, I mean, you could do something funky like that, too. Or it would have to be like this, if I were to do that. Um, hmm. So it doesn't have to necessarily go straight to here. So this one goes either to here or to here. We're not sure which. It could go that way to there. That would give 4 reds here. So then it would have to connect this way. Therefore, this would be 4 and 5 there. That seems fine. You could just connect straight down. You could go here. You could go here. So the possible combinations from here have to be straight down, this way, or this way. Um, hmm. Hmm. This connects either here or here. This could connect that way. Could connect even this way. Actually, can it connect? Yes, it has to go some. No. So I don't think it can connect that way. So it can connect this way, obviously, to go like all the way here. Um, or it could do something funky like that. This is kind of broadly open. It could just connect directly to here and go like that. That's possible. Hmm. Unfortunately, that's not that restricting. So that's why I was trying to think of other things that we could try to eliminate as possibilities. This is 1 through 4. Oh, that's interesting. So say we cannot go this way, right? It would have to either go before that or something, yeah, or something along those lines. Well, we still could do something like this, I think, right? That is potentially possible right now. Um, Actually, is that possible? Well, the thing is, it doesn't have to go the full length here. It could just go like this, right? Even it could just do something like that. And that would still be possible. Hmm. Um, right. So it could do something like that. This with the okay. So that's if so we're looking at this scenario, right? So if we go all the way here, okay. So that's actually interesting. So say we do connect this way. So we have blue, red, blue. Aha! And we have a problem. So if it does connect this way, this must go this way because it has to. This has to connect this way, and this must go this way. But that must be a red, and we have too many reds now in row 4. So it cannot connect all the way here, which means it's going here, here, or here. Can we connect this way or this way? The answer is no. So if we try to go connecting to here, you can't connect to this because then this has to go to there because you can't do this then this because then this is not part of the region, right? And you can't go here to here because now this can't connect to the region because it has to go here and then it would touch itself here. So if it's going down, it cannot go here because that would connect to here. It can't connect to here. It has to connect to this. So if it's going down, it must go this way. But again, as a pattern, this would have red, red, and red. That's 5 reds in row 4, which is not allowed. So this cannot go down. It has to go to one of these directions. So it can't go this way. It must go to one of these two. We don't know which. And it must connect to this, which means that this must connect somehow to here, which means this must connect to here. And this is 1, 2, or 3. This must connect this way to connecting here, or it's doing something like that to there. Could do something funky like that. That is potentially possible. Or you could just go straight there, right? Again, we have 3 degrees of freedom in the circles. That means a 9 could drop 3 to a 6. We are not guaranteed a 9 in every row. A 4 could drop to a 1. We know these are set in stone. So that's 1 through 4. Um, it could do something like this. That's potentially possible. No. So it cannot contain both this and this. So if it did something like that, it would have to go that way, and we'd have 4 reds in row 2. So it cannot enter from this way. It must enter from here. It could exit this way. That's fine. It could exit something like that. That's fine. Could enter that way. That's fine. So this has to either go here, here, or here. This has to either go straight through. It could do something funky like that. It could also go... Can't go like that. It has to go... If it goes this way, so either goes this way, there. If it goes this way, it must continue to there and continue there. Or if it goes... It could go something funky like that. And then from here to here, it could just go straight. It could do something like that. It could do something like that. So this is definitely 6 through 9 here. Oof. We can only have 1/6 region at most. We can only have 2 1 regions at most. We can only have 2 2 regions at most. Hmm. Huh. What happens if this is a 6? You would have 7 8 9, 8 9, and 8 9. That's 3 times 9. So you have 17 at most for the blue circles. So that's 64 at minimum for the red circles. That's 8 and 9, which is 17 times 3, which is 51. So 8 and 9 is 17, times 3 is 51, plus 7 is 58, plus 6 is 64. So that does work. Okay. So this, any random circle here could be 6. What happens if this is 7? If this is 7, this is 1, 2 as a pair. That's 3, this is 4, so 9 would have to be those two. This would be 1 or 2. This would obviously not be 4. No 4 here, no 9 here, no 9 here. So this could not be 4 there, obviously. But that could still certainly be 4. That doesn't really help us much. What happens if this is 4? Okay, let's try that. If this is 4, this is 3, this is 9, that's 8, this is 7. That's fine. That means this can't be 3. There's no 3 here. This 8 eliminates 8 in the rest of the column. 4 means this can't be 4 here. That means this would have to be 9 and would have to go that way. So that would be red. This would not be 9. So this would have to be 1 through 3 there. Oh, also interesting. We do know if this blue either must be going from one of these two. So it must be next to both of these digits, which cannot be 8 and 9. So therefore, this is 1 or 2 that way. If it's between these two digits, it has to be next to a 6, which forces that to be 1. Interesting. Huh. Does that tell us anything? Not particularly. That's why I'm trying. Like right now, I feel a little stuck. I'm trying to figure out how else to approach this. We did figure this part out, where this has to connect to that cell there, because we tried going that way. That doesn't work. I mean, even this still has problems because you have 3 red digits, so you can't ever go this way. If you go this way, it's still, you can't connect this and then connect to the rest of the loop, so that doesn't work. That's why you cannot go this way. That means that's why it's connecting to there. This cannot connect to here because then it needs to connect back to here, which is not going to be possible going this way, right? It would touch itself there or touch itself here, which is why it has to go that way. Can't go do something funky like, well, it can't. It would branch there, which is not possible. Hmm. Okay. Hmm. We do know this belongs to either this region or that region. It cannot be part of this region here. This is too long to get to the blue cells. So it's either part of this region or it's part of that region, which means that these two cells are in the same region and they're part of that or that. So technically, this still could do something like that. That would be possible. Um. Hmm. We do know 4 is here, 4 is here, or 4 is here, which means there has to be 9 in one of these two spots, obviously. Because if 9 were here, then 4 wouldn't be able to be next to any of these digits. We also know then that 9 has to be one of these 3 cells in column 2, because 4 is guaranteed to be one of these 3 cells here. That's why one of these 2 cells is 9. One of these is a 4, and therefore that guarantees a 9 in one of these 2 cells, which means this can never be 9. That's interesting. So that means we lose 1 degree of freedom here then. Right? Because this is 7, 8, 9, 8, 9, and 8, 9 at most. That's 51 plus 7, which is 58. And we can have at most an 8 here, which is 66. And we have to have a minimum of 64 in the red regions. So that means we have 2 degrees of freedom now. which means the 9 can never drop down to Nine can never drop down to a 6 anymore in the rest of the rows or columns. Right? If we try to have a 6, 7, 8 here, that's dropped too many. 6, 7, 8 plus 8, 9, and 8, 9. That's 8, 9 plus 8, 9 is 34. Plus 21 is 55, but this can't be a 9 anymore. Because we know one of these two is a 4. It has to be next to a 9 somewhere, and therefore if it's 4 here, this must go 9 there. If this is 4 here, that must be 9 there. So this can never be 9, which means, again, we are guaranteed a 9 here in one of these 3 spots, in one of these 2 spots, in one of these 2 spots. Which means this can never be 9. Since this can't be 9, this can't be 4. We also know 4 can only drop to a 2 now in this row. So this must be 2, 3, or 2 or 3, 4 here, or 2, 4. So this cannot have, it could be 4 here still. So we know 9 in column 1 must be here. So this is 9, which means this cannot be 9, so this cannot be a 4. Therefore, we know this is a 4 here. Because if this were 4, 9 would have to be there. So we know this is 9, this is 4, which is next to a 9. So this cannot be 9 here. 9 eliminates 9 here. This can't be 4 anymore. This can't be 9. This has to be 6, 7, or 8 here. So this could be 2, 3, or 4. Again, we don't have a 9 anymore there. The 7 or the 8 here, though, could drop to a 6. So we are still okay with those cells. But we have a guaranteed 9 in all of these cells, which is why this can't be 9. This can't be 6 anymore, because this can't drop to a 1 anymore. You can't have 1 and... Oh, you still could have 1. Never mind. This actually still could be 1. This can't be 1, because you could still have 1 and 4 here if the 3 drops to a 1. But what you cannot have is 1 here, because if you had 1 here, that would mean this is 1 and 3 at maximum, which means we've dropped from 3 and 4 down to 1 and 3, and we've lost 3 degrees of freedom when we only have 2 available. But this could still be 1 and 4 dropping from 3 and 4, which means we've lost 2 degrees of freedom there. So that could still be 1. Anyways, this can't be 1 anymore. So therefore, this can't be 6 here. That's interesting. Huh, interesting. So we're guaranteed a 9 here. We're guaranteed a 9 here. We're guaranteed a 9 here. We only have 3 9s available then in these rows. This is size 4 as a region. We have to have a repeat, but it could just be 4, 9, and 9 as part of that repeat, right? You could also have 4, 9, and 4 here, or 4, 9, and 4 here. We don't know. Okay, where next? So that was pretty interesting logic there. Can we duplicate it elsewhere? I don't
think so. What happens if this is a 4? If this is 4, we have 9 and 9, so none of these can be 9. We don't... Yes, it has to do something like that. Because it can't go straight there. So this would have to be 9 and 9. That eliminates 9 from being here and there. Whereas 9 in row 2, it has to be here, which means 9 cannot be either of these, which means this must be 9. These cannot be 9 here. This can't be 9, so 9 has to be there. Oh, and we have a contradiction, because this would be 4 or 9. Bingo! So this cannot be 4 anymore, which means... Okay. This cannot be 4 anymore. We've lost... The 4 has to drop down 2. Because we have 3 and 4 in the row. The 4 cannot drop 1 down to a 3. It has to drop down to a 2. So this becomes a 2-3 pair, which eliminates 2-3 in the rest of the row. And we've lost all our degrees of freedom. So then this must be 8-9, this must be 8-9, and this must be 7-8-9, and this must be an 8, right? This is 10, this is 15 here. 81 minus 15 is 66. We have, that means 8-9, 8-9, 7-8-9, which is 58, and then 8 here. So we know exactly what these are. So this is 8-9 as a pair, 8-9 as a pair. This is 7-8-9 as a pair. And this is 8. Or sorry, as a triplet. That means this is 8. So that's done for these circles. We know exactly how many they are. This can't be 8. This can't be 8. We are guaranteed to be next to a 6 and a 7 here because of the 8-9 pairs in the row. Therefore, this is 1. This cannot be 1 here. This 6-7 pair eliminates 6-7 in the rest of the row. This can't be 6 or 7. It's 5, which is next to 4 or 6. 2 and 3 cannot be next to 6. So this is 7 or 8. We have a 7-8, 7-8 pair here. This is guaranteed to be 8 because of the 6-7 pair in the column and the 5 here. Interesting. 4 cannot be next to 7 or 8, so this is 1. We have 8-9 as a pair here, which means this can't be 8 or 9. It's 7, which makes this 9, which makes that 8, which makes that 9, which makes that 8, which makes this 9, which makes that 8. Interesting. This is fine that way, this is fine that way. This is 8 as a region. Interesting. So 8 has to go through at least here or here. Okay. 1 cannot be here. Remaining digits of column 3 are 2 through 6. Remaining digits of row 6 are 1, 2, 3, 4, 6. Okay. Huh. Okay. Okay, so if we were to get a blue here, it would have to be 4, but the 4 would necessarily have to be next to a 9, which none of the digits of row 2 can be. So this cannot be on the loop, because that would be 4. This cannot be on the loop, because that would be 4. So it has to go this way. So it must go blue, red, blue, red, blue. This is not on the loop. This is not on the loop. This is not on the loop because it would be considered touching. So this must be entering from... It has to be exiting out this way. So this is blue. That means we have 1, 2, 3, 4
as on the loop in column 8? Well, the only one which could be next to a 9, this can't be next to a 9 in this direction. It could be next to a 9 here, though. This is next to a 2 or 3, so this has to be 7, 8, or 9. Where is the 4 in column 8? These are all low. 4 cannot... It would have to be 9 and 9 here, which it can't be 9 here. So this can't be 4. This is a 4 here. This is 1, 2, or 3 here. 4 is next to a 9. It cannot be that way. And it can't connect back to here. So this is not on the loop. So it has to go this way, which means that's a 9. So this is 9, which eliminates 9 here. Where's 9 in row 1? This is a 7, 8 pair, which eliminates 7 and 8 here, so that's 9. This could be 1 through... Cannot be 4. It's 1 through 3 here. Remaining digits of row 2 are 4, 5, 6, 7. Okay, this is 4 that way, 9 there. These are not on the loop. Okay, we have 9 cells in this region, 2 or 3, 2 or 3. So this necessarily goes out there. But we don't, okay, so we don't know if it goes like 3 there, or 3 there, or 2 there. Remaining digits of column 8. No 1 through 4, no 9. So it's 5 through 8. This digit's consecutive with this, so it's 4 through 9. No 8 or 9 here. No 8 here. Okay. Remaining digits of row 4 are 1, 2, 3, 5, 6, 7. So this could go this way if it's 2. Okay, this is 7, so it cannot go this way. So it has to go low here, and it must have a 2 here to be next to the 7. So this is 2, this is 3. So no 2 or 3 here. This can't be 3. 3 is next to only 8 on the Whisper 5 line, so this is 8, that's 7. No 2 or 3 here, no 2 or 3 here. This cannot be on the Whisper 5 line, so it must go this way. That's low, so it's 1, 2, or 3. This must go this way, so this is blue. So it has to be 1 or 2 there. We have a 1, 2, 3 triplet in column 4, which eliminates 1, 2, 3 in the rest of the column. So the remaining column 4 has to be 4, 5, 6, 7, 9. 2 eliminates 2 here, so that's 3. 3 cannot be next to 7 on a Whisper 5 line, so that's 8, which makes this 7, that's 2. 2 has to be next to 7 here, that's 6, this is 1 then. 1 cannot be here in the rest of row 4. So that's done. We have 1, 2, 3 as a triplet. That's fine. That's fine. 2 is here, which means this can't be 2. This is 3. 3 cannot be next to 7 on a Whisper 5 line, so that's 8. Which means we cannot have an 8 remaining in column 8. Remaining digits of row 5. 1, 2, 3, 4, 5, 6, 7, 9. Well, this can't be 1 or 9. No 9 here. No 9 here. No 7 here. No 3 here. No 7 here. No 7 here. No 7 here. Remaining digits of column 2 are 2 through 6.
Hmm. Okay. This is size 3. So can this get a repeat? The only way this can get a repeat is if it goes here or it has 9. Can't be doing something like that. Can't be, could be something like that as long as that's a 4. Um, this cannot be on the line, on the loop. You can't do something funky like that, so this can't be on the loop. So this could go out 1 and then go back. That is possible. But if it were to do that, if it were to go that way, this would have to be a high and can only be 6, and would be between 2 unique digits on the Whisper 5 line. So it cannot go this way. It must go this way. So this has to be not 4, 5, or 6, 7. This is 1 or 2 next to 8 or 9, which means the remaining digits in the column are not 1, 2, 3. It's 4 through 7. Okay. 3 and 2 eliminate 2 and 3 here. That's 1. So this region, again, has to be either 4, including that, or it could go that way, I guess, with that 4. Or it includes both 9s, and that's it. Either way, this cannot be 3 digits here, because then this can't be 4 with a repeat. So this must then go here necessarily, which means this is definitely a border, because these two cells are in the same region. This can't be 9 because of 9 in the row. This can't be 7 or 9. Remaining digits of row 1 are 4 through 6. We have a 4, 5, 6 triplet in column 9, which eliminates 4, 5, 6 in the rest of the column. This can't be 4, 5, or 6. It's 7, which is only consecutive with 6 here. That means this can't be 6. That's 5. That's 6. This can't be 5 or 6. It's 7, which eliminates 7 in the rest of the row. Remaining digits in the row are 4, 5, 6, 9. No 9 here because of 9 in the column. This can't be 5, 6, or 7. It's 2 or 3, and that's 2 or 3 as a pair. We have a 2, 3, 2, 3 pair in row 4, which eliminates 2 and 3 in the rest of the row. No 2, 3 here. No 6 here. It's 5, 7 as a pair. This 6 eliminates 6 in the rest of the row. So no 6 there. No 7 here. No 7 here. Where is 9? 9 has to be one of these two. 9 has to be one of those two. Oh, this can't be 9 anymore. We should have a lot of 9s. We have 7 9s, right. So 9 does have to be one of these two. 9 has to be one of these two. This cannot go that way because it's only 5 or 7. Well, it could be 2, 7. 1, 2, 6. So that is potentially possible. 1, 6. Right. This is size 8. It has to get through somewhere here or here or here. Okay, remaining digits of row 8 or 1 through 7 of row 3 are 2 through 8. No 7 here, no 8 here, no 7 here. 7 eliminates 7 here, so this is 5 and 7. Interesting. That eliminates 7 in the rest of that column. We have a decent amount of 7s now. Where... okay. 5 eliminates 5 in the rest of column 6. This is 5. It cannot go this way, so it must go this way. So this cannot be 4, 5. This is not going that way. This is not part of the region then. This cannot go this way because of the same thing that I was talking about. So this is not part of the loop. We should have actually a lot of 8s now. We have 1, 2, 3, 4, 5, 6, 7, 8. We know where the last 8 has to be. It has to be there. Okay. This 8 does not repeat, and it cannot go this way. And this is 2, so this is done as a region here. Therefore, this 8 has to have 1, 2, 3, 4, 5, 6, 7, 8, and that's it. So this is done as a region because it cannot repeat here. So this is done as a region. Therefore, this cannot have 1 here. It's 2 and 3 because you can't have repeats within a region unless they have a star. So this is 2, 3 here as a pair, which means eliminates 2 and 3 in the rest of the row. This can't be 2 or 3. It's 1. Oops. That's not what I wanted to do. This is 1. That makes this 2, which makes this 3. 2 cannot be next to 6, so this is 7 on the Whisper 5 line, which eliminates 7 in the rest of the column. We have 8 7s. We know where the last 7 has to be. It has to be here. Okay. This is size 3. It could be here. It could be that way. We don't know. This is size 9. If we were to go here, the problem is, I guess 7 could go that way. 9 has to either go out this way, or it goes out this way. We don't know. This is 2, which eliminates 2 in the rest of the row. 9 cannot have a repeat. So that means it's blocked here. Red has to go out this way. So 9. How does this work? So this could go there, maybe. 9 has to have 9 digits in it. So that means it's all the digits from 1 through 9. It probably includes that. Okay, it needs access to an 8. So which 8 can it have access to that is in its region? Obviously, the 8s with circles don't work. And it can't reach this 8. 1, 2, 3, 4, 5. This is part of this region. Can it reach this? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, but then this is not going to be 8 in size. So it can't reach this. This must be part of the region here, which means this is part of that region, which means 2 and 3 are part of that region. So this cannot be here. It has to go this way. We have 2 and 3. Since we have 8 here, it must include all of that. Oh, 6 eliminates 6 in the rest of the column. We need access to a 6 too. So then it must be all of these. So that's a region, which means we have boundary here. This is 3, so that's done here. This must be repeated part of that, so that's fine. If this is loop, we have 1, 6, 1. So if this is loop, this way, 7, 1, 6. If it's going that way, this is definitely 9. So if this is loop 7, 1, 6, this is 9. If this is going through that way, that's a 9. So either way, this is a 9, which means this cannot be 9, which means this is a 9 here. So no 9 here. We don't know if it goes through that way or if it goes this way. We definitely have a repeat here. And I think this is the only cell that can get to this 8. 1, 2, 3, 4, 5, 6, 7. But then this is cut off. So yeah, this has to be part of that region. Can 8 go out this way? So if 8 were to go, 8 can go like this. 8 cannot go this way. Because then this is not going to be size 8. Because it has to go through one of these 7. So if 8 goes this, well, that's... I guess it could do that. That is possible. Huh. This is size 1 or 2, so this must necessarily be part of this region. So that's 3. 9 must have all the digits from 1 through 8. It can get that 8. But then this 7 can't get through. And then these aren't part of a region. So if we try to have this going through here, that's not going to work. 4 can only reach there, and 7 can't get to any of these cells. So these would not, this one would not be part of a region. So this has to be part of this region here. So this is necessarily going to have a boundary there, because we know the one for here, it cannot go this way, because then this one is not part of a region. It has to be part of the 9 region here. This is part of that region also, because if it can't go that way, because then these aren't part of a region. So this cannot be a 6. We have a 4, 5, 4, 5 pair in row 2, which means this can't be 4, 5. It's 6, which eliminates 6 in the rest of the column. We have these are part of the region. So this cell has to have a 5 and a 6. So this cannot be 5. This is 4, which makes this 5, which makes that 4. There's no 4 here. This is 5, 6 as a pair. 4 eliminates 4 in the rest of the column. This is 6. There's no 4 here, no 4 here. No 4 here. No 6 remaining in the rest of the column. So this is necessarily part of the region. It could just include these two. No, it cannot include that. So that's not part of the region because it's only 4, 5, or 6. So this is boundary. We need 3 and we need 2. Well, the only 2 can have access to is here because this is a boundary. So this must be the 2, and that must be part of the region. So then this is done as a region there. That means this cannot be 2. There's no 2 here. Well, we already knew that. This can't be 7 because of 7 in the row. One of these is 1. This is part of the 8 region. This cannot be 4 anymore, therefore this must include both of these. Therefore this is 3 as a region here. So that's done. This must just be 4 there. So that's done. 8 cannot be part of this cell here. Okay.
7 cannot include one of these digits. 8 can't reach there. 9 can't reach there either because it would have to go through there, and this is not going to be size 8 in region. So one of these must include the 1 or 2. One of them has to be here, and then this must be part of 1. Okay. So this can't be, this is not 3 or 6 anymore in the rest of row 6. So this cannot be high, low, high here. So then this must just be that way. So these are not part of, this is 2, 3 as a pair, which eliminates 2 and 3 in the rest of the column. So this is 1, there's no 1 here. Okay. No 2. 2 eliminates 2 here, so that's 3 and 2. That means this can't be 2 or 3 here. This 2 eliminates 2 here, so that's 3. Which means this can't be 3, that's 2, which makes that 3. So there's no 3 remaining in column 6. We have 1, 3 there, and 1, 3 there. Okay. This 8. 1, 2, 3, 4. Okay, we have 3 here. I think this has to be part of the 9 here. Right. It cannot, if we try to include all, we are definite, well, it could do something like this. That is potentially possible. Again, these 7s can only be part of one of these regions in the 8. 9 cannot make it all the way down here because this is part of 9. So we have 3 cells here. There, and 7 cannot be part of that. This 8 can't make it. It's too far to any of these 7s. So one of these 7s must be part of the 1 or 2. Which means this is done as a region here. So this is 5 and 6 as part of this 8. You could do 7, 3, 4, 5. And that would be 4. So that is possible. Or can you go out this way is kind of the question. Or go out this way. You cannot go this way because that would mean you have to have 2 4s here, which is not allowed. Well, there's a guaranteed 6 here, I should say. If you go out this way, this is 4. You cannot go out both this way. So if we try to go out this way, it has to go either there or there for 8 cells. But the problem is, we know one of these 2 digits requires a 1 because we can't have 1 in any of these cells. And we already have a 1 in the region, so that doesn't work. And if we go that way, one of these cells requires a 6, and we can't have a 6 in that region because we already have a 6. So this cannot go this way. It must go this. Oh, this is not part of the region. Shoot. That's not going to work then. Shoot. Dang it. Oh, where did I mess up? I hate this. I hate this. I know I messed up. I just don't know where. No, I'm so close to. I hate when this happens because I know I made a mistake somewhere. I just don't know where.
Uh, hmm. Dang it. It's probably something stupid too. Shoot. Can't go down. Can't go this way. But it can't go that way because it includes a 1. How do I restart this then? I don't know. I don't know where I made the mistake, too. That's the problem. Ugh. It's horrible. The logic was cool. I don't know where I made the mistake. And this is why these very hard puzzles are very hard. Because the execution was you'll mess up somewhere. And then you're just like, how do I solve this now? Ugh, okay. Let's go back. Okay. These are all blue. These are all red. You have to go through here. So this is red, red. That means this is not part of the loop. That means this is blue, blue. This is connecting there. This is not part of the loop. This must be red, red. This is not part of the loop. Therefore, this must be blue. This can no longer be part of the loop. This can't be part of the loop. It would be considered touching itself diagonally. So this must go that way. Therefore, this is blue. Connects there. This is not part of the loop. Therefore, this can't be part of the loop. Therefore, this must go that way. This can't be part of the loop then. Okay. Boundaries. Ugh. I'm so close and I don't know where I made the mistake. But the problem is trying to find your way back unless you have a fairly clear idea of what what the mistake was is really difficult. So again, this cannot be blue. We'll alternate between blue and red. But if we try to go from this way, that's going to have to be blue, which is not possible. So this, because we have 4 blues in row. 9. This has to go this way, so that's blue, which goes blue out there, which means this is red. This cannot be on the loop. It's gray. This has to be, again, there is a repeat. It can't just be 2 digits long because it must have 1 repeat. So this is 3 or 4. We have 1 through 4 here, 1 through 4 here, 1 through 4 here, 6 through 9. 6 through 9, and the reasoning's still the same because we only have so many digits we can have to add up to 81, which is 9 times 9. This is 7, 8, or 9. It's between 2 unique digits. 1, 2, or 3 between 2 unique digits. This is 8 or 9 here, 8 or 9 here. This is 1 through 4 here, 1 through 4 here. Okay. This
So can it go this way? The answer is no. Remaining digits in column. This is, again, 5 through 9, 6 through 9 here. 5 through 9 is only consecutive with 4 through 9, right? And again, if we have 8, 9 here, that would force 6, 7 to be in these 3 cells, but that doesn't work because trying to fit 2 digits in 3 cells means you have a space. So no 8, 9, no 7, 8, no 6, 7. So it could be only 5 here with 4 or 6. Because one of these is guaranteed to be 5, you cannot go both here and then here. So this is out, which means it must go this way. So that's red. This cannot go that way. It would be considered touching itself. So this has to go this way. That's 7, 8, or 9 in between 2 unique digits. This can't be 4. This has to go either that way into there or this way into there. It cannot go that way into here, so it's guaranteed to go through there. So this is done there. This is between 3 unique digits, or 2 unique digits on the Whisper 5 line. So this is 5, 6, 5, 6. So that's still the same. This cannot be 4 anymore if this were 4. So we know one of these two is 4. Oh, this is not red. This is blue. This is 1 through 4. So if this were 4, this would have to be 9. If this were 4, this would have to be 9. Because 4 has to be next to 2 9s on the Whisper 5 lines. Because it's a loop. And if 4 is here, 9 is guaranteed here. If 4 is here, 9 is guaranteed there. Which means this can never be a 9. We've lost 1 degree of freedom already. That means we are guaranteed a 9 here. We are guaranteed a 9 here. We're guaranteed a 9 here. Because none of those 9s can lose. Oh, that's where I made the mistake. This is not guaranteed to have a 9. It could be 9 dropping down twice to a 7. Okay, well, that's not good. So we have 9 guaranteed here. Okay, so that logic was bad. See, sometimes you actually see your logic be not good there. Okay. We have a 4 guaranteed in one of these 2 cells, which means 9 has to be one of those 2. This logic is still the same, right? If you go down, that would mean you have to go to something like that, and then you would have 3 digits which have to have high digits in row 4, which is not allowed. And that's if you go that way or that way. If we try to go something like that, it doesn't work as a loop. So this cannot go this way, which means it's connecting. So it can't go this way because then you have 5 digits in row 2 requiring a high digit. So you have to go through here. Okay. This is 6 through 9. This is 6 through 9. We are not guaranteed a 9 here. We are guaranteed a 9 here, but that doesn't help anymore. This can't be 9, though. Because the 4 in column 1 must be next to a 9. And it must be next to 2 9s. So 4 is there, this must be 9 and 9. If 4 is there, this must be 9 and 9. If 4 is here, that must be 9 and 9. So we're guaranteed a 9 in column 2. So this, I still feel that was probably the solution, though. But maybe one of these doesn't have to be 9. This is definitely 9. So again, we still lost 1 degree of freedom, so we only have 2 degrees of freedom left. So 4 could drop to a 2. 4 cannot drop to a 1, but 3 could drop to a 1 here.
We have 1 through 4 here. This is 1 through 3. This is 1 through 3 because they're next to 2 unique digits on the Whisper 5 line. 6 through 9 here. 1 through 3. If it went this way, it would have to be next to, again, it would have to be next to a 6, which would force that to be 1. If it goes this way, it would be red and red, and it cannot be 8 and 9, so this is 1 and 2 that way. Right, the 9 could drop to a 7 here. That's what I forgot. The 8 here could also drop to a 6, which is why you could still have 6s here. The 7 or the 8 here could drop to a 6. Okay, well, that's a lot of logic that's thrown out the window. It might be useful later on, but unfortunately, this cannot go connecting that way, because then it can't connect back to the loop without touching itself. So it has to go this way. So that's on the loop. It's 1, 2, or 3. Okay, we don't have a guaranteed 9 here. We know that can't be 9 because in column 1, the 9 has to be next to the 4. And one of these are 4, obviously. We don't know if there's a 4 here. Ugh. I still feel like this was kind of the solution, but maybe not. I mean, we went far down this path, but then we ran into a problem, which is this scenario. So I don't know how far we have to go down the other paths. This cannot be 3, because if this were 3, it would be next to 8 and 9, which would eliminate all possibilities for that cell. So no 3 there. This is necessarily a 7 here, which means this can't be 3 there. Okay. Yeah, I really used that 9 there to... Interesting. Okay. So what happens if we do have 2 4s here? Huh. So say we have 4 here. That makes this 3. This is 9 and 9. So then this becomes 8 and 8. And this would have to be 4. So that would be 9 and 9. This would be 7. Obviously this couldn't be 4 here anymore. But 9 would be eliminated from this row. 9 would be eliminated here. Where is 9 possible then? So what are the possible max digits here? It would have to be 9 here as the max, 9 here as the max. That means this is 7, 8 at most. So how does that work? 7, 8 at most, 8 at most, 7, 8 at most, and then 8 at most.
Okay, so this is 3, 4 at most, so we still have 17 possible here. The red cells still need to add up to at minimum 64. We have 9 and 9, which is 18. 7, 8 twice, which is, so, what happens here? 8, 7, 8, 7, 8. That does work, and then that can't be 8. It would have to be 7. So that's the maximum there. What is that? 15, 15, 30, plus 18, 48. It's basically 7 and 8 times 3. 45, plus 9 and 9, which is 63. So you cannot have 4 be here. Okay. What happens if we try to have 4 and 4 here? So we have 4 here, 4 here. This is 9 and 9. That means there's no 9 here, no 9 here, no 9 here. This has to be 9, and this is 9, which eliminates 9 from being here and 9 from being here. So we have the same kind of similar problem, but we could have 9 here, 9 here. This is 7, 8 as a pair, so we could have 8, 7, 8, 7, 8. That, and then this could be 8. Interesting. So in that scenario, this would be what? 15, 30, plus 34. That's 64. And then this would be 3 and 4. Huh. And that might be the solution. Interesting. So what happens if this is 4? I don't think that will work, right? You have 9, 9. This is 3. That's 8. This must be 4, so then you have 9, 9. And yeah, that doesn't work. So this cannot be 4. So we know this is a 4, which means 9 and 9 is here. So there's no 9 here. This cannot be 4. But we could have a 4 there, which would force 9 and 9 to be there. So if this is not 4, it's 2, 3 as a pair. So we've lost 1 degree of freedom here. There's no 4 here. There's no 9 here. This can't be 9. But the thing is, how do we go through all of that then with that as possibilities? We know this can't be 1. So this can't be 6 here. Yeah, we went through a pretty long convoluted path there to get there. This cannot be low as a 4 because this can't be 9 anymore. So then this has to go this way. So that's blue. This is low. It's next to 6, 7, or 8. So it's 1, 2, or 3 here. Which means we have a 1, 2, 3 triplet in row 7. This is not part of the loop. This is not part of the loop. Actually, none of these can be. None of these can be a part of the loop. This can't be part of the loop here. Remaining digits in row 7 are 4 through 9. Therefore, it could go this way if it's 9, 4, 9. That is potentially possible, but then this would have to be low again, and we'd have 5 lows in the row, which is not possible. So it cannot go this way. So this can't be part of the loop. Again, it could do something like that. It could do something like that or that.
This is next to 2 unique digits, so it cannot be 6. This is next to 2 unique digits, so it can't be 6. So it's 7, 8 as a pair. This can't be 4 because it's next to a 7 or 8 on the Whisper 5 line. This can't be on the loop because it has to connect this way. This can't be on the loop because it must connect to here. Remaining digits of column 2. We have 1, 2, 3, 1 through 6. Okay. I'm going to pause here and I need to go to the bathroom. I'll be right back. And I'm back. Let's continue on with this puzzle. Okay. So, we do know if this is 2 and 3, this has to be 8, 9, 8, 9, right? So can this ever be 6 and 9, essentially? That would mean this has to be 3, 4, which means 9 would have to be here. So this can never be 6 here. Right? So assume 8 drops down to 6 here, because we have to have 2 degrees of freedom that we're losing. Oh, wait. Hold up. Okay, so this is 9, which means this can't be 9 here. If we try to have a 4 here, that's going to be problematic. We have 4, 9, 9. That makes this not 9 here. Okay, so then this is still the same. So I still don't know where I went wrong. This would have to be then 6 with 7 or 8. So this cannot be 7 or 8 because this is between 2 unique digits right now. So if this was 4. So, okay, everything I had is still valid then. I messed up somewhere else. Okay, well, anyways. Yeah. So if we had a 4 here, this has to be 9. We are guaranteed a 6 here. And then this is 6 and 8 at most. We'd have at most a 9 here, a 9 here, 8 here, 8 here, 7 and 8, which would make this 6 and 8 at most, because it cannot be both 7 and 8. And that doesn't add up to enough. 6 and 8, 7 and 8, 8 and 8 adds up to 45. Plus 18 is 63, which is too small. So that's why it can't be 4 there. There we go. Well, now we still have the same logic. So this is 2 and 3. Because we've lost the 4 in both of these. It cannot drop a single digit. It must drop 2 digits. Down to the 2, because we already have a 3 guaranteed there. This is 1. Ugh, I don't know where I messed up then. 1 here, 1 here. This is 2, 3 as a pair. This has to be 8 and 9 to add up because we have 2 and 3 here. This is 15, which means the red digits must add up to 81 minus 15, which is 66. Which is 8, 9, 8, 9, 7, 8, 9, and 8. That's 8 and 9, which is 17, times 3, which is 51, plus 7, which is 58, plus 8, which is 64. So we have 8 here. This is 8, 9. This is 7, 8, 9. And this can't be, this 8, 9 pair eliminates 8, 9 here, so that's 7. This can't be 7 or 8. It's 9, which makes this 8, which makes this 9, which makes that 8, which makes that 9, which makes that 8. So that's 7. This can't be 7 or 8. It's 6, which is next to 1 on the whisper 5 line. So no 1 here. This can't be 2 or 3. It's 1. This must go out this way. So this cannot be 1 here. Well, that's kind of good to know. So this is 1 and 2. No 9 here, no 9 here. If it goes this way, it would be next to a 6. If it goes this way, it would be next to a 6 or 7. So this cannot be 3. Therefore, where's 3 in row 9? It must be here. So that's 3. This is 2. That's 3. This is 2, which makes that 3. 3 can only be next to 8 and 9. Cannot go that way then, so it must go this way. We cannot have a 4 in either of these cells because it must be next to 2 9s, and we can't have a 9 here if we go there. We can't have a 9 here because of 9 in the row. So this cannot be on the loop, which means it must go this way. It must go down here. This is not on the loop. It must go here. This is not on the loop. This is not on the loop. This can't go on the loop because it would be 6 with 1 and 1. So it must go down here, then must connect to here. These are not on the loop. And this is still the same. We have, this is next to 8 here. This is 8 and 9 as a pair, which eliminates 8 and 9 in the rest of the row. So this cannot be 8 or 9. It's 7, which makes this 8. So no 8 here, no 9 here. So this is still the same, unfortunately. Ugh. No 1 here, no 1 here, no 1 here, no 2 here. Yeah, it felt like the solution was so close anyways, so that's why I was like kind of confused. This can't be 1 or 2. It could be 3 or 4. In fact, we have to have a 4 in one of these. And this can't be 4 because it's next to 2 unique digits on the whisper 5 line, so this must be 4 here, which makes this 9, this 8, that's 9. This is cannot be 2 here. This is 1 or 3. This is 1, 2, or 3. Next to... Actually, it could be 4. Huh. No, can't be 4. Next to an 8 on the whisper 5 line. So it's 1, 2, 3, which eliminates 1, 2, 3 in the rest of the row. So we have 4, 5, 6, 4, 5, 6, 4, 5, 6. We have a lot of 8s. 6 eliminates 6 here, so it's 5, which is next to 4 and 6 here. This has to be 8. We have a lot of 8s, as I said. Remaining digits of column 3 are 4, 5, and 6. No 4 here because of 4 in the column. No 9 here. Remaining digits of column 8 are 5, 6, and 7, which is consecutive with 4 through 8. 8 can't be here. Remaining digits of row 1 are 4, 5, and 6. We have a 4, 5, 6 triplet in column 9, which limits 4, 5, 6 in the rest of the column. No 4, 5, or 6 here. It's 7, which forces this to be a 2, 3 pair. Remaining digits of 7 is only consecutive with 6 here out of 5, 6, or 7. So that can't be 6. This is 5. That's 6. No 5 or 6 here. It's 7, which eliminates 7 in the rest of the row. 6 eliminates 6 here in the rest of this column. So that's 4, 5. Okay. Remaining digits of row 4. We have 2, 3, 5, 7. Okay. This digit cannot be between both 8 and 7. So it cannot go this way. This has to go turn here. This has to turn here. So this is 2 or 3. And this is 1 or 2 here. We have a 1, 2, 3 triplet in column 4. Okay. 8, 7 cannot be next to 3 on a whisper 5 line, so this is 8, which makes this 7. We have 8 eights. We know where the last 8 has to be. It has to be here. Again, this is blocked off from here. This is 2 as a region, so this must be going that way. So that's done. 3 has to go out this way because it cannot go here. Because then this would not have a repeat. So this 3 has to go at least here. So this is done. That's a boundary. Let's see. This then is blocked here, and is blocked by the 8 here because there are no repeats in that region. So this must be a region like that. So that's 8 as a region. Which means, again, this cannot have a 1 here because we have a 1 in the row. This is 2, 3 as a pair. Sorry, 1 in the region. 2, 3 as a pair, which eliminates 2 and 3 here. It's 1, which makes that 3. Um, 9 again must access an 8. And if it tries, it can't. It must have access to an 8 because there are no repeats in this region. So it cannot go. If we try to go this way, all the rest, well, try to go that way. 1, 2, it can't because this we know this 8 is part of this 3 region. You can't reach here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If we reach here, the problem is this 8 doesn't have an 8 cells in its region. So it must access here. And since it must access here, it cannot go through here. It must go through here, which is 2 and 3. So it cannot have 2 and 3 here. It cannot not contain that region cell. If it did, what region would this be part of? There isn't one that it can be part of. So this has to all be part of the region. Oh, this could be 1. That's where I messed up. That's where I messed up. Okay, so it could contain a 1 here or a 1 here. It cannot, so this has to go, it cannot go all the way here. It needs access to an 8. This has to be a region. So this is a boundary there. 3 has to go out there. 9 is part of a boundary. 4 is included here, so this can't be 4. 3 is included here. Okay, so that's where I messed up. Okay, there we go. Now I know where I messed up. Good. Okay, so then everything is back to normal. And I messed up here. Good to know. We have to have access to a 6. It has to be here. And it cannot include the 3. We cannot include the 4. So it could be 9 and 1 here or 9 and 1 here. We don't know. But we do because we've proven what we know. Okay, so therefore... good. 7 eliminates 7 here. We have a 2, 3 pair in row 4, which eliminates 2 and 3 in the rest of the row. This is then 5. That's 7. No 5 here. We should have... we don't have enough 7s. Anyways, this is 6 and 7, which eliminates 6 and 7 in the rest of the row. So we're looking at... This cannot go 9 to 5 there. So that's not on the loop, so it must connect that way. So this is not on the loop. And this has to be 1, 2, or 3, but cannot be 3 because of 3 in the column. That means the remaining digits in the column are 4 through 7. Okay. This could still be 7 here. Remaining digits in... 9 cannot be here. Remaining digits in row 5. We have 1, 2, 3, 4, 5, and 9. No 5 or 9 here. 1, this can't be 1, 2, 3, or 9. It's 4, 5. That means where's 9 in row 5? It must be one of these two. But if the loop goes this way, it's 7. It would have to go 7, 1, 6 here. And this could not be 9. If it goes this way, that must be a 9. So if it goes this way, that's 7 something, 7, 1, and 6 required. We also know this is a 1, so this can't be 1 here. So if the loop goes this way, it's 7, 1, 6, and then this would be 9. If it goes this way, this has to be 9. So either way, this is a 9. So we have a 9 here, which eliminates 9 in the rest of the row. We have a 4, 5, or column. We have a 4, 5, 6 triplet in the row, which eliminates 4, 5, 6 here. So that's 9. No 9 here. Remaining digits of column 4 are 4 through 7. This is 8. The same logic is here. We have to have a 6 here, because this can't be 6. Same logic here. So we need access to an 8. It cannot go, it cannot contain this. So if we don't contain this, this has to connect to here. This 4 can only get to there, and therefore these don't have a region. So this must be part of this 9, which means it must access the 1 here, because if we try accessing that one and ignoring that, this doesn't have a region. So this must go this way. It has to have 9 digits, so then it has to get to here, which means this cannot be 5 or 6, and it must be part of this region because it cannot ignore that, because then it would not have a region. So this is 4 and connects there. That makes this 5, that's 6. That makes this not 5, that's 4. So no 4 here. This is 5 and 6, which eliminate 5 and 6 in the rest of the region. No more 4 here. This can't be 4, it's 6. So no 4, 6 remaining in the column. This cannot, we know these are all part of this 9 region, so this cannot be part of that region. The 9 needs access to a 2. And the only access to a 2 it has is here, so this must be 2. Which means this can't be 2, this can't be 2, that's 3 and 2 there. Remaining digits of row 3 are 4 through 7. No 7 here because of 7 in the column. This can no longer be 6, so this is 2 and 4 as a pair. Well, that means this cannot go this way, it must go this way. So that's high. These are not on the loop. We know this is a region. So that's done. Okay. And then everything is still the same. This must be 4, 9, and 9 cannot go to here, so that's done as a region. So we have that. Oops. This 3 is a region that way. This 8 has the problem. So, okay, hold up. Remaining digits. Okay, we have repeat there. This is obviously part of that. This 9 must access an 8. Why can't that be 7? I don't know. 6 eliminates 6 here, though. So no 6 is here. Seems fine. So this cannot go that way. It has to go that way. Oh, that's why that's 7. There we go. not in the region. This can't be on the loop, so this must be 7 here. 1 and 2, 1 and 2. We have 3 7s. This can't be 7 here. So where's 7 in row 3? It must be here. This can't be 7. Remaining digits, 1, 3, 4, 5, and 6. This 6 is part of this 8 region, because this can't go down here. That would not be size 8 as a region. 1, 3, 4, 5, 6. No 5 here. 2 eliminates 2 here, so this is 3. This is 2. That's 3, which means there's no more 3 in this column. One of these is guaranteed to be 1. So again, these 7 have to be accessed by a circle. This 8 cannot reach any of them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This 7 obviously can't be part of that region because there's no repeats. This 9 cannot reach any of them. If we try to go there, this doesn't have enough cells in the region. Same with that, same with that. And if we try to go that way, that's too far. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then we know these are part of that region. So that doesn't work. So these must be part of this circle and this circle here. And then one of these, that is 2. So we know then this has to be boundary here, boundary here. This 5 and 6 are part of this 8 region. And if this included the 1, then it would have to go that way. I guess it could go that way too. No, okay, so if we try to go here, the problem with that, I guess you could do something like 1, 2, 3. How does that work? Something like that? Either way, we know this is part of this region now, right? If we try to include this, this would have 8 cells going that way, and we have a 1 repeated in that region. If we try to go that way, then you'd have 1 out of 1 or 6 is repeated here, or 4 is repeated here, which is not allowed. So, and if we try going, these are separate regions. So therefore, this cannot be part of this region here, which means this is boundary there, and this is boundary there. So this is 4 cells in this region. Can this go this way? And the answer is no, because it would have to have 4 here, and then this would have to be 4 or 6, but we'd have a repeat in the region. So this must go this way. So that's 6. It could go 7, 8, maybe. So this is boundary that way, because the 7's part of the 2 region here. We don't know which one. This is boundary here. This must go here. It could be here. If the 2, so let's try going there. That would mean this is 4, this would be 6, and that would be a repeat. So it cannot go 3 there. It must go this way. So it has to go this way into there. So that's 8. Or it could go here. We don't know. Huh. Okay. So it has to be one of these 2. So it definitely has a 1. So it definitely has to include these. So this cannot be 6 here. It cannot have a 5 here. So could be 1, 3, 6 that way. And in fact, this has to be a 6. So actually that doesn't work. So therefore it cannot go this way. Therefore it has to be that as a region. So this is done as a region there. And we have 1, 3, or 4 there with a guaranteed 1 there.
This can't be 6 because it's part of this region as 8. This must be part of 8. And it could either go here and here. Does that work? Maybe. Or it's these 8. So we have 4 here. 4 here. These are part of that region. And it's this or this. So either way, we know there's a boundary here, there's a boundary there. Okay. 8 does not have access to a 9. That is possible. 1, 2, 4, 5 there. Okay, 6 eliminates 6 here. So now we have to figure out these boundaries. 8. Okay, cannot be these 8, right? Obviously, it's blocked here. So if we use this one, it cannot go to here. So therefore, it would have to be these cells. But then we have a 3, 4, 5, 6, which unfortunately has too many digits in the same region. So it cannot contain this one. Therefore, it must contain this one here. So this is part of that region here. This is a boundary. The 7 has to access that. But it doesn't have to go through that way. It can go that way. 1, 2, 3, 4, 5, 6, 7, 8. So this is guaranteed to be part of that. To minimum, you can go that way. So this must be part of that. So these are part of that cell. So we have 1, 2, 3, 4, 5, 6, 7. And that's done as a region. So we have that as a region. This is 8, 1, 2, 3, 4, 5, 6, 7, 8. The only digit this is missing, we have a 4, 5 pair, which in that region, which eliminates 4 and 5 in the rest of the region. This can't be 4 or 5, it's 2. This can't be 4 or 5, it's 6. So no 6 here. 2 eliminates 2 here, so that's 4, which makes this 1. There's no 1 here. 1 and 4 eliminate 1 and 4 are here, so that's 2, which makes this 1, which makes that 2, which makes that 1. So this is done as a region. No 2 or 1 here. This is 3, 4, 5. 6 eliminates 6 here in the region. This then, where is 6 remaining in row 8? It must be here, which makes this 5, which makes that 6. 5 eliminates 5 here, so it's 4, which makes this 5, which makes this 3 and 5. That makes this not 5, it's 4, which makes that 3. 4 eliminates 4 here, so it's 5. This can't be 3 or 5, it's 4, which means this cannot have that 4, so that's a boundary there, which means this is boundary there, and that should be done. So this is 5, this is 4, and that's 5. Woof! That was a bad assumption there. Well, not too bad. I mean, you're bound to make mistakes somewhere in the solve for a lot of puzzles. So you just have to figure out where you made the mistake. And sometimes it's better just to start over from the beginning again. In this case, I don't know. I don't know if I would have been able to spot it just by going backwards. Because assumptions are hard to spot, right? Otherwise, you wouldn't make those assumptions. If they weren't if they were assumptions you wouldn't normally make, obviously it would just not be there. So you have to basically go back from the beginning and then basically question your assumptions on those. It's kind of like science if you think about it. Like you should be always questioning your assumptions and always questioning whether you actually are going down the correct path. But Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.